Hello everyone, welcome back to my YouTube channel. For those of you who are very new to my channel, my name is Rajat and today we are going to prepare a complete industry level loss given default model using SAS. Now, the thing is that SAS is the hot technology in the banking sector. So today I am going to tell you step by step that when you are preparing a loss given default model under the umbrella of credit risk and ECL, that is expected credit loss, how this workflow of LGD model works. So stay with me till the end of this video and I'm going to provide you all the links through the description box of the input data and the SAS code along with it. Always remember, these models are super important for all the big banks. So learning this can land you into a very dream job of you. So guys, first of all, we would be opening, or those of you who don't have the account in SAS, they need to create an account in the SAS because this code you will be able to run in SAS. So you can go to Google and type SAS on demand. Now, when you type SAS on demand, so SAS is giving this free environment to the people who want to learn SAS. Okay. Now, the thing is that I already have an account here. So my account will be automatically logging in. But when you click on this access now, it will take you to a portal where you need to basically your own profile. And you will be entering your individual detail, your email ID, occupation, why you are entering into the environment and all those details. And then you will also see your name right here, just like mine. Now, when I click on launch, so this is basically creating my workspace and the code which I will be working, that will be automatically visible here. Now, when I was working last time, so there was this code open, but I will close this because today we would be going to discuss on the new code, that is the LGD code. So this is going to be the code which we would be working for the day. Now, this is the code. We'll go step by step in the code. But before going to the code, what would be the input for this? So let me open. So there is a file. The file name is UCI credit card. This is the file which we are going to use as an input for the loss given default model. And in this file, you can see the important variables like the ID, limit balance, their sexuality, their education, marriage, age, their payment history, their amount balances, everything is there, their indicator of their defaults. So everything is there. Now, to understand this data, we would be importing this data. This file also you will be able to get in the description box. When you will open your SAS, what is the first thing you need to do? So when you will open, just imagine that you have this side. This is the side which is opening. Once you will open the SAS code, which I will give. Now, in the left hand side, you can see this file option. In the file, you will click, you will see so many options. Then when you need, where you need to go, you need to basically go in this folder. Okay. In this folder, click right and you will see all these options. And then you will click on upload file. So this is the upload file path. This path you will be also using in your code. Now, choose file is something you need to select. When I click on this file, this will be imported. Okay, you can see that the file is already imported in my case because I was checking obviously the code, but you guys can click on the upload. Now, in my case, it's saying one or more file already exists with the same name. So now I don't want to replace it. For example, I click cancel, but you will say import. This will be imported here as this file. Now we can open this file as well. This will open the SAS code which the SAS has used on the backend. So the SAS has used proc import here. Now I'll close this. Don't want to save. Now this is the code which we would be using. Now let me put it full screen. I hope the visibility has improved. Now, what is LGD? First of all, LGD is loss given by default. So when an individual event is happening, what is the loss that event will occur for the bank? So for example, I am defaulting as a customer. Now on that default day, how much loss I will give to the bank? That is LGD And that's for that prediction itself, we create the model. Now, when you see the SAS code, the first thing you see all this green line. So this green area where you have the information of the SAS program, the author, and then the date, then description, what that code does, what are the standard that like this is following the Basel guideline, SR7, SR11 and all that. So this is known as the job card. Okay. This is also you should know the language which we are using, the standard we are using. Now the step one is more about all the step one is all about basically setting up. So in this module, I will be defining all the basically global macro variable assign library references using libname statement and configuring SAS option, putting all the page sizes and the line sizes setting. All these are generic things which I would be doing in this step. From a coding perspective, we are mainly using options. So that is something you need to remember, like libname, file name, and %let statement to create the macros. Another important aspect is maintaining a clean and reusable project structure. So that's what I'm trying to achieve in this. So we are doing some sanity checks also in this level. Usually in all the large banking product, same code may be executed daily or monthly. To keep the environment standardized, we do this kind of setup which you can see at your screen, so that the programmer don't need to work on it every day. We also try to make sure that all library and correctly connected, properly the path is given moving forward without any missing links over there. So that is something we always try to maintain. Throughout this project, you will notice that the macro variable are heavily used in the later steps on the coding to make that the future modifications are much more easier. You just change at one level because that's what the use of the SAS macro. So you do the changes at one level, then just call the reference of that SAS macro. Once the environment is fully set up, we are safely begin to run the code. And the first step would be importing the data. But this was all the sanity. You can see the basic structure, like I'm checking the regulatory norms that as per regulatory, the base score for the customer should be 600, base odd should be 50, PDO should be 20. So all these things, and then we are checking whether the file do exist at this location or not. So this will give you the notification in the starting itself that file do not exist. So as a programmer, it's very good for us that we are not proceeding, we are not running the whole code, and we are checking at the first step. This is the pre-data quality check which we are doing. So in the step number one, that is all we are doing, and then I am putting it into a macro, generate data fallback. Now here the main code basically starts if you have a look at it. So module one is all about importing the file. Now this file was here. So in your case, this code will hit an error because this is my location, guys. Now for getting your location, click on the file, right click, properties. You will see the location of the file in your individual systems, okay, because SAS will give everybody a unique ID. So that is the path you need to put here. Basically, this is the only change you need to perform in this SAS code. Then I will import it using the raw. So basically, now we are importing the raw data set into SAS depending on the source. This could be a CSV file in our case, but it can be an Excel workbook, a SAS data set. Here I am using the proc import to read the file and automatically identify variable names and formulas. After importing this file, we verify whether the data has been loaded correctly using proc content or proc print or not, because these are the procedures which are getting used. So that's what we usually do, the market practice. Basically, these two procedures help you to like verify if your any issue is there in the imported data. This verification step is very important because sometimes data types are incorrectly assigned. For example, a numeric variable may be imported as a character, which can later cause a error. So we also check the number of observation in this step. That's what we do. And variables to ensure that the imported data matches the original source data. At this stage, we are not modifying any missing values or any value overall on the level of the column. Our objective is simply to load the raw data exactly received from the business team. Once this import is verified, we will ready to begin and reassessing the quality of the data. That's all we do in this particular step, right? So this is our step which ends at this level. A labeling of the column is also performed so that now you are standardizing the name of the column which you are going to use here. Now, next step is quality audit and logic check. So before building any model, we need to assess the quality of the data. So for that, we are using proc sort here, and then we are performing a certain check. So in this module, basically, we identify duplicate records, missing value, invalid observation, and an inconsistent data type. We also generate descriptive statistics to understand the overall distribution of the variable from a coding perspective. So we are using proc frequency sometime and proc means also sometime to understand that what are the dynamics of the data. Here I am keeping it short and simple to understand so that everybody don't get confused seeing so many procedure, right? So that is the beauty of the SAS, because it gives you so many procedures which are getting used on directly for a particular target. Okay, so for example, if a customer age is recorded as a negative, just assume, or if the recovery amount exceeds the total exposure, these records immediately indicate whether inconsistency in the data need attention or not. So that's what we try to achieve, some abnormality. These quality check provide confidence that data set is reliable before we begin any feature engineering going forward on this one. Okay. Now let's talk about the module number 3. So guys, before building any model, we need to assess the quality of the data. In this module, we will identify duplicate records, missing value. We try to do that, and invalid observation, inconsistent data types, all these. We also generate descriptive statistics to understand the overall distribution of the variable. From the coding perspective, you can see that we are using proc summary here, and basically sometime we try to use proc frequency, proc content, proc sort, no dupe key option. All these things are used. So if you are new to the SAS programming, I think you should explore all those options. We carefully review minimum value, maximum value, average, frequency distribution, all those things. We try to achieve that. Okay, now in this you can see that we do have the proc summary. Now proc summary and proc means have a quite similar function. Proc means is also used for the statistical information. Proc summary is also used for the statistical value calculation. So basically what we are generating here is output of this module actually help us to decide how much pre-processing would be required. That's what we are trying to do using proc GLM. Okay. Then we have the next step, that is the automate missing value. Basically, we would be checking the missing value things here. So missing values are very common in banking data sets and cannot be ignored at all. That is something you always remember. In this module, what I am trying to do, we are calculating the percentage of missing value. Okay, you can see proc means. As I said, proc summary, proc means are very informative procs. So we would be checking the missing value and decide the appropriate treatment. So numeric variables are typically imputed using the median and mean option, which you can see on your screen, while the categorical variables are replaced with the most frequent category. In SAS code, usually we perform this using the data step logic, if then else condition, then proc, SDT size, or custom macro depending on the project requirement. By the end of this module, every variable is completed and ready for modeling. And we would be running all these modules one by one, but let me give you a little brief about each of those module so that we have at least some theory in our hand so that we functionally can accept the code. So guys, the next module which we have is the outlier detection module, which is all about outlier detection and Winsorization. So basically, credit data often have extreme value like impossibly high credit limits that can completely skew the model. So that's why we are using proc univariate to find the first and 99th percentile for all our monetary features. Then we use a data step with min and max function. You can see at your screen to gently cap those extreme value, ensuring that they don't drag regression line, of course, while preserving the overall shape of the data. That's what we are trying to achieve in this particular part. Okay. So SAS coding is beautiful. Just learn that. Okay. Now the module 6. What is module 6? So we basically need to split our freshly cleared data so that we can actually evaluate our model performance lately. We use proc survey select to create a clean 70-30 random split, setting a specific random seed to guarantee that our results are 100% reproducible every time we run this particular SAS code. This gives us a solid training data individually bifurcated to build the mathematics and hold out test separately to serve our overall out of sample reality checks also, because we keep data into those two parts. So we need to keep in mind that if we need to go out of sample reality check at the end, so how we will do that. So that's what we are trying to achieve using this particular module. Then we talk about the module number 7. So we basically tackle monotonic binning and fine classing, the relationship between a borrower age or credit limit and their actual default loss isn't always a straight line. Just remember this. So to handle this, we write simple if else logic to group continuous variable into logic discrete buckets, simply like grouping asset into 10 simple band, okay, 10 separate years of band. This makes the model much more robust to minor fluctuation and easier for the business side to interpret. That's what we are doing in this module number 7. Next module talks about continuous metrics computation. In this module number 8, where we calculate the continuous metrics for the bin we just created actually in the previous module, I built a custom SQL macro called calc_LGD_bin_stats, which you can have a look at your screen. That is the name of the SAS, the SQL macro. Now that calculates the mean, standard deviation and the count of the actual loss given for every single bin. We then stack these together to create a summary table that shows us exactly how risky each bucket of the borrower historical is. That is again very important because we are checking on the historical level, right? Next module number 9. Now we have been working through an algorithm, right? So now the next step here comes as a dynamic mean target mapper. For module number 9, we perform what's called basically target encoding using a dynamic mean target mapper using proc SQL. We join these historical average of LGD value back into our model training dataset. Instead of feeding the model the raw age or the categorical bin name, we feed it the historical loss severity associated with the specific group so that it doesn't get distracted, which gives us regression model to a massive production boost. Now here comes the overall production boost. You can have a look that this is the dataset will be created in the module number 9. Now next is our module number 10, where we are checking the multicollinearity assessment. Before we actually build the final model, so module number 10 act as a safety check by assessing multicollinearity. We run proc correlation, proc reg with the VIF option to calculate the variance inflation factor, that is a full form of VIFs. This basically ensures that newly targeted encoding feature aren't too highly correlated with each other, otherwise they are useless for us, which would otherwise confuse the model and make the regression coefficient unstable, which we cannot handle, or which we don't want. Handle is not the right word, which we won't want as a model developer in the module number 10. Let's move to module number 11. Now module number 11 is the simple regression LGD model fitting. In module number 11, where the real mapper happens, the real math is happening also, I would say in this way, fitting the regression model. That's what the target is. We use proc reg with a stepwise selection method on SAS, so that SAS automatically keeps only the variable that are significantly and statistically at a 5% level. Crucially, because LGD, which is loss given by the default, represent a percentages, we add a quick data afterwards to basically tightly constrain all our model prediction between 0 to 1. That's again very important. Now let's talk about module number 11. So now you have checked the complete multicollinearity, you have checked the regression LGD model fitting. Now we are basically diagnosing and residual analysis something for the model. So in this module, we evaluate how well the model is learning by running model diagnosis and residual analysis. We calculate the raw residual, which is just like the actual LGD minus our predicted LGD. That's what the target is. Like actual versus the predictive value. That is something we check. Along with the absolute and squared residual. Using proc summary, we roll these to check average error and ensure that model isn't systematically predicting too high or either too low. Both are not good for the model. Now let's talk about the next module. So module number 30 is the LGD performance metrics. Module 30 formalizes these diagnostic into basically standardized continuous model performance metrics, which is a quick proxy step. You can have a look at the screen. So we calculate root mean square. We call it RMSE, root mean square error. The MAE also we calculate, and R square value. MAE stands for mean absolute error. So these value we check. Now we are calculating these value. That is clear to us. These metrics provide the model accuracy and are exactly what you need to basically present to the risk committee for the approval of your model. Now this risk committee concepts comes within the bank. So every bank have like multiple layer of security. So the model risk committee is always the approver of all those models, right? Now let's talk about the next step. So I'm giving you the whole pipeline. I'm just not developing the model and leaving the model. Okay. I'm giving the whole pipeline. Model developed. Then we are doing calibration. We will be sending the file for the committee approval. Then we would be checking certain model validation techniques also. Now in this step number 14, basically module number 14 is dynamic scorecard point allocation. Now we basically pivot to the business side in the module 14. As of now, we were doing all as per the model. Now we would be checking the business side, the dynamic scorecard point allocation. That's what given by the business team, because we would be doing score for every individual customer. We define our scaling variable, a basis score of 600. You remember at the step number 1 on the top, and base odd of 50 to 1 and 20 points to double the odds. Okay, we exact the beta coefficient from our regression output and apply the industry standard scaling formula to convert those statistical weight into easily readable whole number point for every variable bin. I know this is going to be too technical, but just try to memorize all these words, guys. This is going to help you in your next interview. In this step number 14, that's what we are trying to overall achieve. Okay, you can have a look at this code obviously, and then you can simply make notes when I'm talking about each module. Now module number 15, it takes that pointed logic and apply it to individual borrower level using a score scaling and a calibration engine. We transform our capped LGD percentage predictor into a logit function. We have created a logit function here and scale it to calculate a final 3-digit integer score. That's the target. We floor the score at a 300 and cap at the maximum, that can be 850, making the output instantly recognizable to everyone familiar with the standard scores, which whether those are your business team, validation team, risk committee, any individual member in the bank. Those are the generic score. That's why we keep them. Now module number 16, decile analysis generation. To prove the model makes logical sense, module 16 generator decile analysis. We use basically proc rank. All of you know the proc rank to sort our score account from the highest risky to the lowest risky customer and chop them into 10 equal buckets or decile, whatever you want to call it. We use proc summary basically to compare the predicted average LGD versus the actual LGD value in each of the bucket of the customer, ensuring that the model rank order risk perfectly across the entire portfolio, so that there should be no unfair distribution of the data and everything should be crystal clear and easy to understand. Now, next module is your cumulative lift and gain engine. Now, what is the purpose of this? So basically, when we talk about module 17, that takes those decile which we have created, and build a cumulative lift and gain matrix by simply comparing the actual default in the highest risky deciles which are available against the overall portfolio average. We calculate a lift multiplier. This basically directly show the business how much better is this model. Identify several loss compared to just guessing at a random level. That's why this is step number 17. Cumulative lift and gain engine is important for the after the calibration and overall decile analysis. Okay. See, all of those things you will see in this step, then your stability check step will come. So, which is the part of your validation? Population stability index monitoring. What is the meaning of this? How stable is your population in different scenario? That's the purpose of, that's the end goal of PSI calculation. Module number 18 is critical for the model governance team also, because as a developer you need to provide them the data, right? So calculating the population stability index, or in short we call it PSI, we finally bring our 30% which we kept, right? The holdout test data set, run it through the exact same binning and scoring logic, and comparing the distribution of the test score against our originally training scores. And most important thing to remember here is, let me just first scroll it down a little bit, because this is the whole calculation. Now, one important thing to remember is that a strong PSI metrics proves to the validator that the model hasn't been overfit or remain stable. It has remained stable on the completely unseen data. That's why this module is very important. Again, I will repeat this thing, that when you run it through the exact same binning and scoring logic, and compare the distribution of the test score against our originally training score. So that's the end goal of this PSI whole module. We check in the output once we will run this code. So you can see this is the computation we are doing on the basis of the band different, and then we are doing output will be stored in this data set. Now let's talk about the next step. So the next step is here. Now in this step, basically module number 20. So module number 19, you can skip, guys. It was there, but when I was preparing the code, just don't get confused. After 18, it's directly 20. Okay, just be clear on that. Now, module number 20, what we are doing here, this is basically production scoring batch pipeline. Skipping to module number 19 right after 18. What it means, we package everything into a production scoring batch pipeline. You have done the scoring, the grid has been structured, the wrap the entire data preparation, binning, target encoding, score scaling logic into a single module SAS macro. In a real banking environment, this is the macro that runs on the server overnight. You feed it the raw data portfolio every time, monthly or quarterly. It basically splits the production ready LGD score completely and automatically. That's the automation the bank usually want every individual to do in this area. Now we have achieved everything. We have got the score, we have bifurcated the deciles, everything. We have checked the PSI stability of the model, everything we have achieved. Now in this is more about the reporting. So finally module 21, you can see it handles the executive reports which you generate in your team, and then you send it to various other team. We use the output delivery system, that is ODS functionality in SAS, specifically for PDF. So to automatically generate a clean formatted audit report, it seamlessly pulls a binning summary, perform metrics, decile table, PSI result into a single polished PDF document that is ready to handle straight to regulators, and you can just give a pre-check before giving it to the regulator as a model validation team. And the model risk management team also do check all this. So basically developer creates all these reports, send it to the MRM team, the model validation governance. They then send it to the regulator after validating it. Okay. Now you guys can have a look at this file. So I ran this code before showing it to you, but let me delete this file. So don't get confused that how come this file was there. Because this file, now you can see it's only the input file. Now when I click in the SAS code window, Control A, click on the run. This is the run option. So this code has run successfully. Okay. All of you can see the output window has also come. All the data sets which we have generated in the work, those are there. You can have a look at the score data set. So you can see all the important columns here. Then if you go to the results, you can see the GLM procedure, basically all those procedure whose output are printed, all the important statistical level informations which are printed here. So you can see that R square value and coefficient, MSC value, actual mean, all those value has been printed here actually. Let's also try to understand a little bit more about these outputs. So you can see the output from the GLM procedure has been populated. Now proc GLM has certain functionality. You generally generalize basically the linear model provider baseline look at how categorical variable affects the LGD. So you can see the target distribution. So basically to simplify this, you can see the target distribution, the average LGD, which actually across your data set, you can see what is the value. You can see here, which is 0.6, which is typically 65.3%. And then you can see the predictive power using the R square. The model explains like 10.7% variance in LGD, while the low value that is relatively common for a credit model before feature engineering is usually applied here. Now you can see the feature significance like sex, education, marriage, pay, all these value, and strong driver you can see in the case of the education, that is 176%. This one. So this is very important. Now let's see the output of proc means. So basically proc means it cleans the data. Proc means is confirming you exactly 30,000 observation with zero missing value across all the exposure, demographic and behavior metrics. Then median baseline is something which is it is setting. Even though there are no missing value to replace, proc is helping successfully calculating the pseudo median for your complete pipeline. For example, the median borrower in your data set is 34-year-old. You can see. So that's what your proc HPI Impute tells you. Now let's move forward in the proc service select output. So in proc service select, basically you can see split ratio is there, then train size is there, then reproducibility is there. In reproducibility, the random seed ensure that you will get the exact same records every time you will run this script. Okay, so I think this is pretty much the decoding of the output. Now guys, to understand the output basically, so in the code, when you will run the code, obviously you know where is the output. The final output in our case is the data set name with productions code portfolio, which is stored in the output. So now if I go in the output on the left hand side, you have to scroll in the outputs. Okay, this is the output module. So inside the output, I have to search for this productions code portfolio. Now I'll click on anywhere. I'll just type P. So it will automatically take me to the P section. So productions Scorecard portfolio. So you can see this is a SAS dataset, which I'm talking the final dataset, which I'm going to explain because this was the ultimate agenda. And then I've created a CSV file. You can also download this CSV also to easily understand the output. Download file. So this is downloading in your download and you just click on that, it will open. So this is your final output. If I zoom it, okay, so you all can see ID, limit balance, sex, education, marriage, all these variable are customer identification or the core demographic variable in our output. Then you can see the payment behavior, financial history, this pay zero amount and all those values are coming. Then we have the feature engineering starts from the bin. When we did the feature engineering, all these variables which are starting with bin. So feature engineering obviously we created, and in the end here is the final grand output of all our hard work in this complete session. Okay, we get our logit LGD prediction which tells us the exact probability of loss, but look at the final column, score production. So this is the standard 300 to 850, considering 300 as the lowest and 850 as the highest. Scores are calibrated. This basically transform complete this whole risk segment math into simple 3-digit score that a bank loan officer can use instantly to make a clear decision on whether to approve the loan or change the credit limit. So that's what decision it takes. Okay, it is fully functioning Basel compliant LGD scorecard built entirely in SAS from scratch. If you found this tutorial helpful, please hit the like button, subscribe for more risk related content to my channel, and let me know in the comment section if you think that you want to understand any other new concept. Also, before closing this video, I would like to request, please share this video with your friends and the people who are trying to crack a job in this sector. Also, you will be able to download this SAS code and the output and the most importantly the input. SAS code and input from the GitHub repository mentioned in the description box. So make sure you hit the like button. Thank you so much. All the best. Also a bonus tip guys, by knowing and doing all this coding, you can crack your interview in any of the big MNC banks.